Hey, it's Random Code here, and today we're going to talk about a concept I use quite often in Java, which is the concept of being able to iterate through a list and then applying some kind of functionality to each element in that list. And we're going to be doing this by calling a .stream.map on any kind of iterable entity, so more or less a list, a queue, a stack, a set, or something similar to that. And just to showcase, I will be using a simple list, so I will have a simple list of integers. And I'm just going to call these numbers. And they're going to be a new array list of some integers. So I'm just going to create a list of, just to show it works, let's create some very simple numbers like that. And of course it's not used, but the functionality I then often would use, let's say we have a use case of we need, now this is a very simple use case, but more often working some kind of API or something. You might have a list of users. You might need to update the type of user on each of them. You might change them to a different data type or something like that. But to showcase the concept, we have a list of numbers. I will then do my numbers.stream.map. And this is very much a functional concept, so a concept from functional programming, where what we're actually doing is that we're iterating through a stream. So a stream is just like taking all our data points and then accessing them one by one. And when then looking at them one by one, we can then apply a function or some kind of functionality. And often in Java, we would use a lambda expression, which is more or less just an inline function. So in this case, we know that we have a integer or any number. So I might do a number. And then we create a lambda expression. And we can either do it on one line or multiple lines. If we do it on one line, we'll automatically return all the data that's like left when doing our exception, when doing whatever we're doing. Otherwise, if we're doing multiple lines, we need a return. But it's a very simple example where we say we have our number from our stream. So we're going to take each of the numbers. We're then going to do number plus 1. And for now, if we run this, we will see it's not actually doing anything, because when doing this, what's actually being done is we're going through the numbers one by one, and we then contain them in this area. They're not actually being updated in our list. So what we need to do is either create a new list, or we can do again our numbers equals our stream.map. But for now, this is just a stream of data that has been updated. We then need to call collect with a collectors. I prefer just to list. I think that's a bit cleaner. So very simply, we're going through all our numbers one by one using a stream. We're then mapping, meaning we're calling a function on each component, or each number in this case, in our list. And when we're then done updating all our numbers, we're then going to collect them into a list and return them back into our numbers object. So we're kind of like overriding our numbers object. We're not updating it, but we're overriding it. So now, if we run it again, we should see that our numbers are now been updated to be 2, 3, 4, 5 instead of 1, 2, 3, 4. And now I'm doing it inside my product void main. So this is a bit tricky, but just to showcase, instead of doing a lambda like this, we could also actually use a function. So we might have some kind of, let's do a private. And note, what's very important is that this map then need to take a function of input type of the list and output type of the list, return type of the list. So we need a private method that returns an integer. Let's do an int, some kind of int mapper that also take an integer number. And then just to do the same thing, this int mapper function, very simply, is just going to take our integer number and return our number plus 1. We can then use it up here. Note in this case, it's a bit noisy because we're using it like in a static context. So we actually need to create our main equals new main to actually access our private method down here. But just to show this example, so instead of just doing a lambda like this, which is like an inline function, so note we're doing the exact same thing of our number plus 1, where here we're just directly accessing the number from our stream. We can now simply do our main object and int mapper like this. So 2 semicolons, or 2 colons just, and then the method name. And note, everything just works and should work the same as before, which you see again, 2, 3, 4, 5. And note, it's very important here that the input and output, or not as much the output, but mostly the input need to be the same of the type matching the list. So if we change this to a double, it's gonna fail. But let's say we keep this an integer, like that, but we change it to return a double. Of course, it's gonna fail now. We're then, of course, in this case, gonna have an issue because we are returning it to the same numbers object before. But let's say we create a new list called doubles, and then create a local variable, our doubles, and then we actually don't need this. But of course, now down here, this is gonna be an integer still. So that's if we just actually do like maybe divide by 2, like that. And we should now see that we end up getting, if we actually print the correct object for doubles instead of our integers or our numbers, we should see that we now get our list of doubles. And of course, this would work the same more or less with the lambda. Yes, but otherwise, I hope you enjoyed this showcase of how we can use the stream.map on anything that's iterable in Java. If you did, please leave a like and subscribe, and I wish you all a wonderful day.